Allora, buonasera a tutti, benvenuti sulla mia piattaforma Universal Talk. Sono veramente felice oggi di ospitare un ospite appunto internazionale. Abbiamo con noi il professor Scott Solomon. Benvenuto tra noi, biologo evoluzionista della Rice University di Houston. Poi ho anche altri due ospiti che mi aiuteranno in questa serata. Abbiamo Eleonora, che è un'astronoma amatoriale e membro dell'Associazione Celesta Taurinorum di Torino. Benvenuta Eleonora. E anche
Grazie.
Paolo Navone, che è tecnico aerospaziale, che è impiegato presso il Polo Aerospaziale Torinese. Grazie Paolo di essere qui con noi. Appassionato
Ciao
di
Marina.
spazio e fantascienza, scrittore e ricercatore indipendente in temi storici e archeologici. Parlo un attimo, vi presento un attimo il professor Scott. Ho già detto che è un biologo evoluzionista della Rice University di Houston e il suo lavoro si concentra sul futuro del genere umano. È uno dei massimi esperti mondiali nel rispondere a una domanda che ci poniamo da sempre. L'uomo si sta ancora evolvendo? E oggi Scott sarà con noi perché presenterà il suo nuovissimo lavoro che è Becoming Martian. Non è un libro di fantascienza, ma è un vero e proprio manuale biologico su come la bassa gravità e le radiazioni dello spazio potranno trasformare i coloni marziani in una specie completamente nuova. Io vorrei chiudere qui la mia presentazione, vorrei lasciare la parola a Paolo ed Eleonora che appunto mi faranno da tramite, in modo tale che sarà poi il professor Scott Solomon a presentare il suo lavoro. Grazie.
Grazie Marina.
Grazie Marina. Welcome everybody in our platform, Universal Talk. The special talk of tonight meet Professor Scott Solomon, an evolutionary biologist and a professor at Rice University in Houston. I'm Eleonora Raia, an amateur astronomer, space enthusiast, and space artist, member of Celestia Taurinorum in Turin, Italy. Good evening, Scott and Paolo.
Thank you, Eleonora. I am Paolo Navone, writer and aerospace technician with a 30 years career in Italian aerospace industry and participating in several NASA, ESA, and ASI program. So I'm proud to good evening, Scott. It's a pleasure to meet you. And so now Eleonora will present you as you deserve.
Will present us his new book, Becoming Martian, which I recommend everyone to purchase to participate in the debate about the big issues we talk actually in space exploration. He is a research associate at the Smithsonian Institution National Museum of Natural History, author of Future Humans, named in 2017 as Best Book by the American Association for the Advancement of Science, AAAS. He is also the host of Wild World with the Scott Solomon podcast and co-writer and co-producer of Becoming Martian podcast. But now let's pass the word to Scott. Thank you, Scott.
Thank you, grazie. Thank you so much to all of you. Thank you for the opportunity to be with you and to share a little bit about my work. So I will pull up some slides here. Okay, so this you see the slides okay? Yes? Okay.
Yes.
Yeah.
Great. Okay. Yes. So thank you again. As you heard, I'm a teaching professor at Rice University in Houston, Texas, in the United States. And the book that I'll be talking a little bit about today is called Becoming Martian: How Living in Space Will Change Our Bodies and Minds. It was published by MIT Press in February of this year. And so I thought I would start by talking a little bit about the incredible mission that we all just got to witness, the Artemis II mission, which sent this crew of 4 astronauts around the moon. This took them to the farthest point in space that any humans have ever been. And provided these incredible views, one of which you can see on the right-hand side there. This is a photo that they took from the capsule looking at the far side of the moon and looking back towards Earth in the distance. I don't know about all of you, but I was absolutely captivated by the entire mission, following along on the live stream and listening to all of the astronauts describing what they were seeing in real time, and also hearing them after they came back talk about what the experience was like. This was truly a historic mission in many ways. But it's not only about what they accomplished on this mission, it's also really about what the plans are for moving forward. NASA has announced very recently that they are planning to build a base on the moon, and the Artemis program is really the steps to get us to that point. And so the NASA administrator, Jared Isaacman, laid out the plans for how they intend to build this moon base, and even provided a timeline for it, as you can see in the image here. So they are already in phase 1, which the Artemis 2 mission was a part of, testing the spacecraft that will be used to transport people from Earth. They will then be transferring to a lunar lander, and the plan is that next year they plan to test the ability of the Orion capsule to dock with the lunar lander. And then in the next year, 2028, they plan to begin landing on the moon with crews, and then soon after that to begin building the infrastructure for having a base. And by the early 2030s, the plan is to have people operating on that lunar base. This, though, is still a stepping stone towards an even more distant goal, which is to send people to Mars. So the idea is that by establishing a base on the moon and learning what happens to people in that environment and what is needed in order to do things like harvest local resources, including water, and also to grow food in order to support a crew, we can learn those lessons on the moon, and that will then enable us to go all the way to Mars and to establish a human presence on Mars as well. So the idea is that we are currently in an era in which plans are being made and being, the activities are already taking place that will lead us eventually towards having humans on Mars. So my question as an evolutionary biologist is, what happens if these efforts are successful? I'm very interested in the human side of all of this. So I find all of the rockets and the spacecraft and all of that engineering absolutely fascinating. But my area of focus is what happens to the people that are traveling on these spacecraft and that are spending time on these remote outposts. So I wanted to start off by talking a little bit about what we know about how the conditions of space affect the human body. Yesterday was the 65th anniversary of the very first human to go to space, Yuri Gagarin, Soviet cosmonaut who spent about 108 minutes, I believe it was, on a spacecraft that took him on almost one complete orbit around the Earth. I think he was about 100 miles shy of one complete orbit. But at the time of his flight, we really had a lot of unanswered questions about what happens to the human body in space. The Soviets had already sent a dog, Laika, into space, and that proved that it was possible for life to be sustained in space, at least for some amount of time. But there were still basic questions that we didn't know, such as, is it possible to swallow in space? This was actually unknown. So one of the first things Yuri Gagarin did in space was to squeeze some food into his mouth and swallow, and he wrote down in his notebook, swallowing is possible. So we were still answering basic questions about basic physiological functions at that time. Of course, we've learned a lot since then. Some of this has been from studying the biological effects of people living on space stations. The Soviets, once again, were the first to do this. They had several space stations, starting with Salyut, and then the American space program moved forward after Apollo to include Skylab. And that was the first instance in which prolonged visits to space were being done by American astronauts. A lot was learned during that mission. It was a series of 3 missions, actually, about the physiological effects of prolonged space exposure. Things like motion sickness, which is quite common for people as they first adjust to the conditions of space. And the fact that our body fluids shift from being primarily in the lower body to being more in the upper body, including the head and the face, when gravity isn't pushing them down. This was also when it started to become clear that astronauts need to do exercise on a regular basis, because without having to work against gravity, muscles become weaker, and that in turn causes bones to start to become more brittle. There's also an increase in height. Astronauts tend to get taller in space because the soft tissue between the vertebrae in the back are not being compressed. They expand, and that causes people to become a bit taller. And the curvature of the spine also changes. It becomes more straight, and that causes people to become taller. Now, many of these effects are reversed after people come back to Earth. So they don't stay taller, they go back to their original height. The fluid shifts start to go back to the normal, and they start to rebuild a muscle strength. But there are also some effects that we now know that are not reversed. And this is in part is known from studies like the NASA Twins study, in which astronaut Scott Kelly spent about a year aboard the International Space Station, while his twin brother Mark Kelly stayed on Earth. And researchers were able to look at a lot of different comparisons between what was happening to Scott Kelly and what was happening to Mark Kelly back on Earth. One of the things that they noticed is that there were mutations in Scott Kelly's chromosomes. So these are actually structural changes to the sequence of DNA in those chromosomes, and there was a higher rate of that in Scott Kelly compared to Mark Kelly. This is thought to be caused by radiation exposure in space, and this is not something thought to be reversed. So this could be really a permanent change that could happen to DNA that is very important for us to understand for thinking about spending longer amounts of time in space and traveling to deeper space regions such as Mars. There were also changes to the expression of DNA, of genes, in Scott Kelly's in the study of Scott Kelly's DNA. So this means that these genes are being turned on or turned off. So those genes are producing a product, a protein that has a function in the body, and that's thought to be a way that the body adjusts to the conditions of space. There were also changes to his microbiome, the collection of bacteria and other microorganisms in and on the human body. And we know that this is now something that has been followed up on in other astronauts and has been shown to take place as well. The microbiome largely goes back to normal after returning to Earth, but those changes to DNA, including in particular those mutations, are not thought to. One of the other ways that we've learned about the impacts of being in the space environment is by doing simulations of space travel. And this includes doing what are called analog studies, in which crews spend some amount of time ranging from days to weeks, months, or even years in a simulated space environment or an analog. This is an example of an analog that I visited several years ago in the desert in Utah, the Mars Desert Research Station. One of the things that we can study in these analogs are the psychological effects of being in an enclosed environment, being in an isolated and confined environment, and being in an environment where the only people around you are your other crew members for a long amount of time. And this is a very important factor for thinking about what will happen to people who are staying in a moon base or making the trip all the way to Mars, because we need to consider not only the physical changes to the body, but also the psychological changes that will take place. So NASA summarizes all of these challenges when it comes to humans in space in these 5 categories, or 5 hazards of human space flight. So space radiation, we have talked a little bit about. isolation and confinement, distance from Earth. The farther you are, the more risky it becomes, because if there's a medical emergency, it would be difficult to bring people back. And we just recently witnessed the first ever medical evacuation of a crew from space, when a crew on the International Space Station had to be evacuated back to Earth because of one of the crew members experiencing a medical emergency. That is relatively easy to do from the International Space Station, because you can get a crew back within a matter of hours or days. But of course, it takes longer to do that from the moon. And if you are on Mars, it would not only take much longer, 6 to 9 months, but you can only really do that about every 2 years, when Earth and Mars are relatively close together in their orbits. We've talked a little bit about changes in gravity, and just the fact that these people are in a closed environment surrounded by a very hostile environment. So all of these are challenges that we need to consider when we think about what happens to people in space. But I want to shift now and talk about whether we can ever really truly live in space. It's one thing to go for a short amount of time, or even a relatively long amount of time, with the plan of coming back. And we can learn much more about what will happen to people on the moon, which has partial gravity, 1/6 the gravity of Earth. We can maybe learn about what will happen to people on Mars, that has 1/3 the gravity of Earth. Both the moon and Mars have higher radiation exposures than even astronauts on the International Space Station, because they don't have any protection from a magnetic field or magnetosphere. But if we are ultimately interested in becoming a multiplanetary species, if we want to truly live in space, this would require people making one-way trips and truly living their lives there. And very importantly, it would require having children. It would require human reproduction. And the bottom line is that we know very, very little about whether human reproduction is even possible in the conditions of the moon or Mars, and whether there would be any sort of negative health effects for a child born in that environment. One question is, could a child who was born and raised in a lower gravity environment, such as the 1/3 gravity environment of Mars, would their body develop in a healthy way? We know that adults lose bone density at a rate of about 1.5% to 2% per month. We don't know whether the bones of children whose bodies are growing and developing would form in a robust and strong way, or whether it would be dangerous for them if they were to come back to Earth. If you come from Mars to Earth, you would weigh 3 times as much, and if you're doing that with weakened bones, that could be very dangerous. Another challenge that I think is important to consider is whether infectious diseases caused by microorganisms might limit the ability of people to easily move between planets. A child born in a space environment, whether it's the moon or Mars or a spacecraft, would only be exposed to a small amount of microorganisms like bacteria and viruses, only what we bring with us. And here on Earth, we know that we're always exposed to microorganisms, but our immune systems develop in such a way that most of those are not dangerous to us. A child that's born and raised in a low microbiology diversity, without a lot of bacteria and viruses in that environment, might become very sick if they came back to Earth and were exposed to all of our microbial diversity. So I'm interested in the long-term consequences of having future generations living out among the stars. And when I think about our solar system and the many other solar systems in our galaxy, this reminds me quite a bit of something that I know a little bit more of, which is islands. Because as an evolutionary biologist, we think of islands as being the living laboratories for understanding evolution. I decided to become an evolutionary biologist when I had a chance to visit the Galapagos Islands when I was a college student. And of course, this is where Charles Darwin was inspired to develop his theory of evolution by natural selection. Biologists keep going back to islands to study evolution because these are such clear places to understand how being in an isolated environment with conditions that are different from elsewhere cause organisms to adapt and change. So I believe that if we were to be successful in creating settlements on other worlds, whether it's the moon or Mars or anywhere else, we should expect that future generations living there would adapt and evolve and change over time. Some of the things that we know about how species change on islands include that species often change size. So we have many examples of giant animals living on islands, from these giant tortoises in the Galapagos Islands to the world's heaviest insect, the weta, the giant weta of New Zealand, and another New Zealand species, the giant moa, now extinct, but that once stood about 4 meters tall. So these are incredibly large animals whose ancestors were much smaller, but by being in an isolated island environment, gradually over many generations, they became larger and larger. But the other change to become smaller also commonly happens on islands. There are many examples of very small animals that have evolved on islands, from these tiny frogs and lizards to small versions of mammoths and other elephant relatives. So some of the smallest animals in the world are animals that evolved to become smaller after being isolated on an island. The question is, would the same processes happen to people? And we know that actually there's at least 1 or 2 examples that seem to suggest that they do. We know from fossil evidence that a species of hominid, Homo floresiensis, that stood only about 1 meter tall, lived on the island of Flores in Indonesia. It's believed that the ancestors of this species were taller, about the height of modern humans, and that by being isolated on this island over many generations, they evolved to become much smaller. There's now a second species of small-bodied hominid that was also discovered on an island in the Philippines, Homo luzonensis. And this seems to be a separate, independent evolutionary instance of hominids shrinking in body size after being isolated on islands. So I think we should consider changes in body size as being one of the possible outcomes of being isolated on another planet. Humans living on Mars might become much smaller. Ultimately, though, I think many of the changes that would happen to future generations of people living out in space are changes that would happen on the insides, changes that would happen to our DNA, our biochemistry, our cells, things that wouldn't necessarily make those people look that different from us here on Earth, but could actually cause them to be physiologically different in many ways. For example, in the functions of their immune systems, or in the timing of circadian or circannual rhythms, the controlling of how our hormones are released, which is triggered largely by the orbiting of rotation of the Earth and the orbiting of the Earth around the sun. If you're on a different planet when those conditions are completely different, that could lead to those types of evolutionary changes as well. So I think that the evolution of new human species on other worlds is quite possible if those efforts to become multiplanetary are successful. And the last thing that I want to say is that we might let these processes play out naturally, but we might decide that that's not what we want to let happen, because what I've been describing, this process of evolution through natural selection, is a pretty unpleasant process. It requires a lot of death and suffering in order for future generations to adapt to new conditions. Of course, we would want to avoid that if at all possible. So another possibility is that rather than letting evolution play out naturally, we might decide to take it into our own hands. Rather than allowing a new human species to evolve on its own, we might take advantage of what we know about the biology of organisms on Earth that are able to survive in extreme environments, such as tardigrades, which are known to be able to survive not only long periods of drought, very dry conditions, but they've even been brought to space and have been exposed to the vacuum of space and to the high radiation environment of space. And we even know a little bit about how their genes allow them to tolerate those conditions. And so researchers now are working on trying to take those genes and put them into human cells. And some early studies have shown that human cells with these tardigrade genes are able to tolerate higher radiation exposures. There are some organisms that are even better than tardigrades at surviving radiation, though. Microorganisms like Deinococcus radiodurans and Thermococcus gametolerans are able to survive radiation exposures even higher than what people would be experiencing on the moon or Mars. If we can understand the genetics of what's allowing them to do that and put those abilities into human cells, it could really prevent a lot of death and suffering. But aside from genetic changes, we might also incorporate technology into our bodies. The idea of a cyborg actually first was developed in a paper in 1960, in which the authors were arguing that in order to enable human spaceflight into deep space, the best thing to do might be to merge human and machine in order to enhance the abilities of the human body to handle these conditions. We're already working on technologies such as brain-computer interfaces that allow things like controlling a computer with your mind. And so if we take that type of technology and imagine being able to, say, control a rover or a virtual avatar like a robot, that might really enable us to truly explore space with brand new abilities. So perhaps the next species of human might look something more like this, a mixture of human and machine. So I'll stop with that. I want to thank you for your time and for listening. I'm happy to answer questions if we have a little bit of time left.
Thank you, Scott, for your presentation. And I would like to remember you about the book, Becoming Martian, How Living in Space Will Change Our Bodies and Minds. And the other book, Future Humans, Inside the Science of Our Continuing Evolution. Now I have a question for you.
Yes.
Humans are preluding to become an interplanetary species. How do you see Martian humans? Should we use genetic engineering to prepare them to live on Mars, or technology could be enough to colonize the red planet?
Yes, exactly. I love the question. It's just what I left off with in the talk. So I think that we probably do want to explore the use of genetic technologies and cybernetic technologies, because at the end of the day, we are creatures that evolved on our planet. We are very well adapted for the conditions on Earth, for the 1 gravity, 1G environment, for the amount of radiation that we typically experience here on the surface of Earth. And we know that we can handle being in other environments for short amounts of time, but we don't know much about what would happen to, say, children. And so I think we want to do as much as we can to alleviate suffering, to prevent unnecessary suffering, unnecessary death. And if we have the ability to use genetic technologies to do that, I think we would want to do that. But we have to make sure we can do it safely and responsibly. And we need to think very carefully about the ethics of doing this, because of course we have a long history of making poor choices when it comes to making decisions about future generations and believing that we can control our own future without fully understanding what we're doing. So I think these are technologies that are amazing, but also very powerful, and we need to make sure we fully understand them before we move forward with using them.
Thank you.
Scott, I have a question for you too. Rice University is so famous about the speech of JFK, in which he gave the future vision of space exploration related to, of course, to the moon. So, looking at the future of Mars target, what if your vision is fascinating you for the most, and what is scaring you about the most about this new frontier.
Yes, thank you for the question. So you're right. Yes, just down the street from where I'm sitting right now is the football stadium where President Kennedy gave his famous speech in which he said, "We choose to go to the moon, and not because it's easy, but because it's hard," right? And so I think it's worth reflecting on that today, because we know how hard it is to not just to go to the moon, but to actually live there. And so if what we're talking about doing is to create a permanent base on the moon, or to create a base on Mars, and especially if what we're talking about is to truly live there and have children there, this is something very difficult. This is not just a small step forward. It really is a giant leap. So for me, I think it is very exciting. I'm very excited about all of the efforts in human spaceflight. I think the idea of being able to actually send people to Mars is incredible, and I'm very excited about that. I think the thing that I'm most excited about is what we might learn by going there. We've learned a lot by sending robotic probes like rovers to the surface of Mars. There now is a lot of evidence that seems to suggest that there may have once been life on Mars. This is incredible. As a biologist, I'm so excited about this and excited to learn more. If we send people there, we will be able to very quickly advance our understanding of Mars, of whether there ever was life on Mars, about whether there could still be some surviving life somewhere on Mars, perhaps deep underground. So this to me is very, very exciting. But my concerns are that we maybe move forward too quickly. I want to make sure that people understand how really risky it is to send somebody all the way to Mars. It is much more dangerous than just sending somebody for that same amount of time to low Earth orbit, like the International Space Station, because of the things that I was talking about before. Once you're on your way to Mars, you're not coming back for at least 2.5 years. And we could have medical emergencies like we had recently on the International Space Station. We have to know how to solve those medical emergencies there. We have to know how to feed people. We don't yet know how to grow enough food in space to support a crew of people for 2.5 or 3 years. We need to understand whether being in that high radiation environment beyond the protection of Earth's magnetic field, whether it will have serious effects on DNA, on our chromosomes, whether it could lead to, increased cancer risks or other concerns. And then again, going back to the idea that people might eventually decide to raise children there, I think we need to be very clear about how little we understand about what would happen with human reproduction and child development. So those are the things that concern me. I just want to emphasize that we have a lot of questions that we still need to answer. And I hope that we get those answers someday. And once we do, I think we should move forward with all of those plans if we can. But we have to make sure that we're doing it responsibly and safely.
Yeah. I agree with you. And so thank you, Professor Solomon. I'm hoping to have you back soon to discuss maybe next steps for our evolution, and we wish you actually a good night, and see you soon for a new interview and new other questions to answer us other questions in next time.
Thank you, Scott. Good evening.
So much.
Thank you.
Thank you.
Thank you.
Grazie quindi al professor Solomon, e grazie anche a Eleonora e Paolo per essere stati con noi qui questa sera. Vi aspetto per un'altra puntata di Pillole dal futuro, sempre sulla piattaforma Universal Talk, che potete appunto trovare sui principali social, quindi Facebook, Instagram e YouTube. Vi ringrazio e vi do appuntamento alla prossima puntata. Ciao!